I believe that's all my work and answers all squeezed all on one page right there. So they give us a differential equation, which remember is the slope. And the first part A, you're just supposed to look at those hash marks and see which way that curve is kind of going there. I would kind of start at the point that I'm on, that they want us to pass through, and then just, hey, the direction is going that way, and then just trace it along, then the direction is going that way, and then just kind of trace a curve right there. All right, that's all you got to do for part A. So just practice that a little bit. Sometimes we have to do that. Part B, write an equation of the tangent line. So you need 2 points, a point and the slope. Right there, we have the point. So to find the slope is we plug that point into the first derivative. So there's my first derivative. It has x's and y's in it. So for the x, I got to plug in the 1. For the y, I got to plug in the 2. So you see my work right there. Sine of pi over 2 is 1. Times it by 1/2, times it by 3, we get 3/2 for the slope. Do your point slope form. There's the equation of the tangent line for full credit, but that's the first part of that. The other part that says use the tangent line to approximate f of 0.8. So whenever I use the tangent line for something, I'd like to actually solve for y. So I solve that for y, you see my work for that. And then I'm gonna take the 0.8 and I'm gonna plug that in. Now, you could do it with the decimals. I felt a little bit more comfortable doing it with the fractions there. So I know that the 0.8 is, actually I just did 0.8 minus 1, and then that gave me negative 0.2, which was negative 2/10. At that point, I was switching some things, the fractions right there. So sometimes I'll try it with decimals if they're small enough. And then at some point I might change the fractions if I'm having a little trouble with something. But please practice that on your own without the calculator right there. So then you multiply by the 3/2, move the 2 over, careful with your arithmetic. I'm getting this 1.7 or 17 over 10 number there. And make sure you read the directions. You got to find the equation of the tangent line and then use it for something. Make sure you're doing all parts of that problem. All right, letter C. We've seen these before. It tells us the second derivative is 0. We know that automatically means the function is concave up. Is that approximation that we found in part B an overestimate or an underestimate? Give a reason for your answer. So you use the tangent line to approximate something, and the curve, the second derivative is positive, so the curve is concave up. So I like to just do this little picture here. And so since my curve is concave up, the tangent line is actually below the curve. And then that means your approximation that you found in part B was down here in the tangent line, but since the curve was concave up, the actual value is up there. So you could reason out a little bit, but I just put the approximation as an underestimate since that f double prime is positive. You could say that f double prime is positive. You could say f is concave up and the tangent line is below, something along those lines there, but you need this, the second derivative is positive or the function is concave up. And then I know if it's concave up, the tangent line is below the curve, making it an underestimate. If my second derivative was negative, that curve would have been concave down. Tangent line is above the curve, and it's going to be an overestimate. All right, letter D is the last part. It says use separation of variables to find the original function, the particular solution of the differential equation. All right, so you know what that means, and that's in our blue packet, those directions there. You ought to find the particular solution to the differential equation. So you know that means you're going to get to move the dx over, and then you got to do legal algebra. Legal algebra, separation of variables means separate them, get the y's with the dy, x's with the dx. And then once you have that, we'll integrate both sides. Remember the plus c, we'll plug in our initial condition that they give us to figure out what the c value is. And then we'll plug in our c value and we'll solve it for the y. So this is going to be a strength of ours. And let's just practice this without the use of the calculator. Now, so I multiplied both sides by dx. You lock those differentials into place. And then you have to get the y's over here with that dy. So I just divided both sides by the y's. And then now I have the y's with a dy, x's with a dx. It doesn't really matter what you do with the constants there. I know ultimately I want to get y equals something there. So if I have any extra numbers or anything like that, I typically like to just leave those on the right-hand side. But if you put the 2 on the left, it's not going to make a difference. You're going to have to move it back over anyways. So be real careful. Do a u du here and a u du here. So u is the inside of the radical. That's a 1 over radical u. So integrate that, go u to the positive 1/2 divided by 1/2, so times it by 2, plug your y's back in. And then here your u is the weird angle, your du is that pi over 2, so balance out with the 2 over pi. The 1/2 carries down, so those 2's cancel out. When you integrate sine, you're going to get a negative cosine, plug those x's back in, and we always stick the plus c on the side the x's are on. And then at this point, it's very important that you find that constant of integration that's worth more points. So right away, stop after integrate, get that plus c in there immediately when you integrate it. Use that initial condition to give you, take the 2, plug it in for the y, take the 1, plug it in there for the x. The cosine pi over 2 is just 0. And then you get 3 times 2 there. So you get your c is 6. Pop that back in. You have the majority of your points on this thing. And now all that's left to do, so I took this equation here, and now all that's left to do is solve it for y. So I divided everything by 2, divided that by 2, divided that by 2, and then I just squared both sides. And then after we square both sides, you move the 7 over. You got the y by itself. We're done with that. Please practice that. We need to be perfect with that without any mistakes. That is not something difficult. That is just something you just got to be a little bit careful on. But every single one of us can just crush that integral and then crush this problem there and study those little details right there. Tie clip.